We are busy with topic 16, the area and perimeter of two-dimensional shapes, and we are focusing on solving problems involving the perimeter and the area. We can calculate the area of composite shapes by dividing them up in plane shapes. So for example, here we have a rectangle and then we have two triangles. So we can simply divide this composite shapes into its simplest shapes and calculate the perimeter or the area of each of the plane or simple shapes and then add them up to get the area of the complete shape. So here we have 6 different areas or perimeters that we will calculate and then add them all up to get the complete area of them all combined. Similarly, here we have 2 simple shapes. We can calculate each one's area or perimeter separately and add it up to get the whole composite shape's area or perimeter. So let's make use of exercise 16.3 to illustrate these concepts. So first of all, number 1, we need to calculate the areas of these composite shapes. So first draw a sketch to show how you have divided up each shape. Give your answers to one decimal place. Use 3,142 as an approximation of pi. So here we can't use 22.7 or 3,114. It has to be specifically 3,142. So let's study this figure. So what I see is we have a 16,5. These two sides are parallel. Here we have a 15,3 and even these two sides are parallel, so this seems to be like a rectangle. So you know, opposite sides of a rectangle are the same length, so this should also then be 16,5 meter. And then it seems we have here trapezium, because again we have the parallel sides. The one is much longer than the other side. We have the length of this, the shorter side. We have now the length of the longer side due to the properties of a rectangle, and we have the perpendicular height of this distance between the short and the long side of the parallel sides of the trapezium. So we have in fact everything to calculate the area of the trapezium as well as the area of the rectangle. So we actually have 2 areas that we can calculate, and then we can add them up to get the area of the composite shape. So let's first focus on the rectangles. So the area of R for rectangle we know is simply the length times the breadth, or length times width. So now we know in the place of length we have 16,5 meter. In the place of the breadth or the width we have 15,3 meter. So now it's simply a matter of using our calculators. So we have 16,5 times 15,3, and we will obtain 252,45, and meter times meter is meter squared, So we know the final answer we need to give to one decimal, but this is not yet the final answer. This is only the answer for the area of the rectangle. We still have to calculate the area of the trapezium. So we will only round to one decimal right at the end to keep our answer as accurate as possible. That's a general principle in mathematics. When you round rather in the last step to keep your answers accurate. So now let's calculate the area of the trapezium. Well, we know the formula for the area of the trapezium. We add the shorter side, we add the longer side. Let's call the shorter side we usually refer to as A. The longer side we usually refer to B. And then we have the height. So get the average of the shorter plus the longer side, meaning add them together, multiply by a half, or to put a different way, add A and B together, divide by 2 to get the average, multiply by the perpendicular height. So now we can substitute. In the place of A, we have the 6 meter. In the place of B, we have the 16,5 meter. And the height, the perpendicular height, is 4,8 meter. So brackets first, according to BODMAS. So we have half times 6 plus 16,5, 22,5 meter times 4,8 meter. So now we can use our calculators. We simply multiply everything. So we have half or 0,5 times 22,5 times 4,8, which will result in 54. And meter times meter is square meter. So now we can obtain the area of the composite shape. It is simply adding the area of the rectangle to the area of the trapezium, which is 252,45 square meter plus 54 square meter. So now if we add those two, we get 306. We have to round to one decimal. Here's our first decimal. The neighbor on the right is 5 or bigger, so our decimal place will have to increase by 1. 4 plus 1 is 5. So it's 306,5 square meter. That is the area of the whole composite shape. So now let's go to A. First at B because it's less steps. Let's now focus on A. A, probably there are more than one way to calculate this. There are various ways, so I'm just going to go with one way that works for me in a sense the best. So what I'm going to do is I'm going to complete this so that this is a solid shape here. So we have 6 and 4 is 10. We know this is 4, we know this is 4, we know this is 4. So 4 plus 6 is 10, plus 4 is 14. We have 18 in total. So we know this must also be 4 meter. 4 plus 4 is 8, plus 6 is 14, plus 4 gives 18. Yes, it works. Then I'm also going to complete this shape. So let's see what we have here. Well, we have 6, 7. So what is 11, 5 to 6, 7? That will give this distance. 11, 5 minus 6, 7. So we can borrow here. So we have 15 minus 7, it's 8. We can borrow here. So we have 4. So let's just test. 6 plus 4 is 10. 7 plus 8 is 15. Okay, so it's 1, 5 plus 10 is 11. Yes, it works. Okay, so therefore we know that this portion here is 4, 8. Okay, so now for me the easiest way is to say, okay, let me just calculate the area of this whole shape. Let's just for a moment assume there are no gaps. Okay, so I'm going to calculate that area. And I'm going to say this is a rectangle, so it is length times breadth. So it's length times breadth. And then what I'm going to do is I'm going to subtract the gaps, okay, because we want the area without the gaps. So I'm just going to subtract the gaps. So here we have 4 by 4 by 4, so it's a square. So I'm going to subtract length squared or side squared. And then we have the rectangle, because it's 4 times 4, 8. So this is going to be another length minus breadth to calculate that rectangle. So let's say the big one and we have the small one. The big one is like the complete one, and then we have the small one. So now we have everything we need. So the complete area, we have length in each place 18. In the place of the breadth or width, we have 11, 5. And then I'm going to subtract 4 by 4. So it's 4 squared, or 4 meter squared. So now let's just put the 2 on its proper place. Minus, we also want to get rid of this gap, which is the length is 4, 8 meter. And the breadth is 4 meter. So now we can calculate each separate area. So firstly we have 18 times 11, 5, which results in 207. Meter times meter is meter squared. So that's the whole big shape if there were no gaps. Now we subtract firstly this little gap. So we know 4 times 4 is 16. Meter times meter is meter squared. Similarly, we have to calculate the area of this gap and subtract that. So subtract as it reduces out the area of the composite shape. So we have 4, 8 times 4, which results in 19,2, and meter times meter is meter squared. So now we can simply subtract the gaps from the whole to get the actual shape's area. So it's 207 minus 16 minus 19.2, which will result in 171,8 square meter. Yes, so let's have a look at number C. So I see here we have 12 millimeters, here we have 3 and 4. So 3 and 4 is 7. So what's this? Yes, 12 minus the 3 minus the 4. 12 minus 7 is 5 millimeter. So we know this is 5 millimeter. We see this is 8 millimeter. We have 4 millimeters, so then this height here will have to be also 4 millimeter, this perpendicular height, because 4 plus 4 will result in the 8. So yeah, this we can approach. For me, the easiest is to approach it similar to the previous one. I can calculate the area of the big shape if I assume this area is full, and then simply subtract the area of the small triangle. So I can say the area is equal to, well, what do we have here? Length times breadth, because it's a rectangle, minus, what do we know about the triangle? It's half base times height. So now it's simply substituting. The length is 12 millimeter. The breadth 8 millimeters. So we replace breadth by 8 millimeter rather. Minus half. What is the base of the triangle? Well, we calculated it. It's this 5 millimeter. And then finally, what's the height? We also calculated that. The 8 minus 4, it's 4 millimeter. And now it's simply a thing of multiplying. 10 times 8 is 80. 2 times 8 is 16. 80 plus 16 is 96. Millimeter times millimeter is square millimeter. Let's look at the triangle size. So 5 times 4 is 20. 20, half of 20 is 10. So we have to subtract 10 millimeters squared. Millimeter times millimeter is millimeter squared. And now finally 96 millimeter squared minus 10 millimeter squared results in 86 millimeter squared. So there we have our area for the blue shaded portion. Number D. The circle has a radius of 20 millimeter. Okay, so the radius, so if you go to the middle of the circle, the radius is 20 millimeter. Okay, so we have an equilateral triangle, meaning all the sides have the same length, has a perimeter of 105. So how do we calculate the perimeter of a triangle? It is side plus side plus side. But now all the sides are equal. So let's just first start in the general case. Side 1 plus side 2 plus side 3, where they all don't have to be equal. But in this particular case, they are all equal. So we can simply replace them all with side. So side 1 is actually side, plus side 2 is side, plus side 3 is side. They all have the same length. So we can actually say it is 3 sides. Now we know the perimeter. The perimeter is given as 105, so we can replace the perimeter by 105 millimeter. So 3 sides is 105. So what's one side then? Well, we can divide both sides by 3. So then the side is equal to 105 divided by 3. So 3 goes into 10 3 times. Remainder of 1, 3 goes into 15 5 times. So it's 35 millimeter for each side. So it's 35, 35, and 35. So now we want to calculate the area of the shaded region. So the shaded region is our circle. So we know the area of the circle. We have to subtract the area of the non-shaded part, which is the triangle. So we can say we have the area equals the area of the circle, which we know is pi radius squared, and we can subtract the area of the triangle, which we know is half base times height. So we have the radius. We know pi, they indicated we have to use 3,142 as the value of pi. We know the radius is 20 millimeter. So we can replace the radius by 20 millimeter and square that. We know we have half. Now we need to calculate the base and the height. So we know the base is 35 millimeter. The problem is now the height. We don't have the height. We will have to calculate the height, the perpendicular height. Okay, but since this is now an equilateral triangle, this will cut these into equal parts. So we know that one part is 35 divided by 2, which is 17,5 millimeter. So we have 35, we have 17,5. We know this is a perpendicular height, so we can now make use of Pythagoras. It says go opposite the 90-degree angle, look at that side. That is the longest side, so square it. So we have to square 35. So we have 35 squared equals the sum of the squares of the two shorter sides. So the one is 17,5 squared plus the other one is the height, which we want to know, which we don't know at this stage. Height squared. So now we can swim across the river. So we have 35. We have 35 squared minus 17,5 squared equals h squared. So when we swim across the river, the positive becomes negative. Okay, so now to our calculators. 35 times 35 is 1225. We subtract, what is 17,5 times 17,5? 306,25 equals height squared. So now we can subtract. So we subtract 306,25 from 1225, which results in 918,25. No, 75, sorry. So that is equal to the height squared. But we don't want the height squared, we simply want the height. So we have to take the square root on both sides. So therefore height is equal to the square root of 918,75. So we need the square root of 918,75, and that will result in 30,31. So we can replace height with 30,31 millimeter. And now it's simply calculate. So we have 3.142 times, what is 20 times 20? Yes, 400. So times 400, so we have 1256, 8 millimeters squared. We can calculate the area of the triangle. So we have half, or 0.5 times 35 times 30,31, which is 530,425. Millimeter times millimeter is millimeter squared. So subtract the area of the triangle from the area of the full circle to get the shaded portion. So if we do that, we obtain 726,37, but remember we now have to round to 1 decimal, which is, if we look at our 1 decimal to the right, we have a 7, it's bigger than 5, so we have to add 1 to our decimal of interest, so it becomes a 4. 3 plus 1 is 4. So it's in fact 726,4 millimeter squared.